So we'll do some examples in Sage and also look at some other functionality. When you go to CodeCalc in your project, in the Math 315 project, you should now have these three folders. The latest I put in was the DE examples, and homework 3 contains the template for your homework. First, let's take a look at the DE examples. Let's go in that folder. So when you click on this, it opens up the Sage worksheet. Let's go to the top here. So what I've done is entered some text here describing what we're doing, and I just want to point out this is done in what's called markdown, and any cell that starts with a %MD is interpreted as markdown. Now let's look at what does that mean? Well, I've actually entered this text in a cell up here. If I click on this arrow, it will expand the cell that produced this text. So this cell starts, so let's see how I did that again. See, I'm just toggling this triangle up here. So if you start with the command %MD, it interprets everything in here as markdown, which is a type of typesetting, or it's actually like a language of sorts. And then if I click anywhere in the cell and hit Shift Enter, that's how you enter commands in Sage, it spits out this down here. Now you might think, well, what's the point? It just makes it a different font. But there's a lot more functionality to it. For example, down here I can typeset this mathematics, which is really cool. And then and also for producing documents, it makes having things typeset is nice. So after having done this, I'm going to collapse that cell, so I don't need to look at it. I'm going to show you how we entered a few of these other typeset math expressions. So how did I do this? Well, let's expand this cell here. It's another markdown cell. Within markdown, you can typeset things in latex. And latex is a typesetting program. The mathematics expressions in latex all begin with either a single dollar or double dollars. So I have double dollar signs enclosing the mathematics expression. The double dollar signs make it display style, so it comes out offset by itself. And if you look, okay, so as you learn LaTeX, you're just going to use examples that you've seen. So here you can see that the fraction is produced by the /frac command. And then the numerator and denominator are both just delimited with braces. So the /frac command makes this fraction. We know it's not a fraction, it's actually a derivative, right? But it's displayed as a fraction. So all commands in LaTeX begin with a slash, with a backslash. Okay, so let's collapse that, and a little bit of commentary is explaining what I just explained here. Okay, another block of comment here. So we want to solve this equation. So what we'll do is enter the code in Sage. So we'll open another cell and enter Sage code. Remember, we needed to define the variable, independent variable, and the function as a function. So for each, whenever I want to put comments, I will just type a %. So these cells here, they're not markdown. This is just Sage code, right? Because there's no %. If I typed a % markdown over here, then it would interpret it as markdown, and when I execute this, it's going to spit out something else, right? So this is not a markdown cell here. We just want to execute Sage code. Okay, well, in any computer language, it's often good practice to comment your code. And for our purposes, like, we don't have to do that so much. I'm going to do it when I want to tell you what I'm doing. And you might want to do it to remind yourself what you're doing with any particular bit of code. Okay, so the pound sign, anything after the pound sign is interpreted is not executed by Sage. All right, so here's how the syntax goes, and we've seen this before. And if I shift enter anywhere in the cell, it will execute the code. And you can see it's grinding away here. You can see this green bar, and eventually it spits out the solution. And we have two, it was a second order equation, so we have two arbitrary or constants of integration. Notice they're preceded by an underscore. So we can actually typeset this, as was pointed out by Kayla, that it doesn't really look that great, but if you wanted to typeset it nicely, you could use this typeset mode true command, and it actually prints it out really nicely, and that's kind of cool. The only drawback is that if you wanted to copy and paste your output and use it somewhere else, you can't copy and paste this so nicely. It won't come out well. But if you had, if you just had the non-typeset, you could copy and paste it. Okay, so here's how we do some other types of things. Again, I'm just commenting what we're doing. Here's how you define a function, and then we might want to evaluate it at 2. So let's see what we've done here. I've set the typeset mode to false, but actually that command was executed after these other two commands. So it actually typeset it nicely. Okay. So now that the typeset mode is false, if I re-execute this, it should typeset as not nicely typeset. See that? Okay, so we don't really need this typeset mode false over here. It's just something I put in there. Here's how you plot. Shift enter. And there you go. You can also adjust the y-axes. Just as a note, if you want to enter a new cell, you're going to mouse over one of the dividing lines and hit enter. If you look up here at this menu, we have some selections which will give us templates or sample bits of code for doing different things. For example, if we wanted to do a numerical integration or say symbolic, there's the command for it. So I want to integrate this function and with respect to x. Okay. Which is exactly, and I'm going to erase that. I don't need it. It's exactly what we did down here. Symbolic integration, numerical integration. So you want to go through and execute all these and just see that they work. Okay. What else? Oh, slope fields. Here's how you're going to do the slope field. So we have differential equation of the form y prime is a function of t and y. Your sheet won't have this little typeset expression here. I just added it. So over here we want to plot the slope field, so we define y as a variable. We didn't have to define t as a variable, interestingly, but that's just because our function is only a function of y. Yeah, it does work. If it didn't work, that would be the first thing to do, would be to define also t as a variable. Okay, so now we have Newton's law of cooling example. So a couple more examples for you to look through. Okay, so I'm going to close. Here's a cool feature of the CoCalc platform. You have this time travel here. So if you made some error, you can hit Control-Z, which undoes things. But what if it was you really screwed things up? Well, you can go to time travel here, and let's see if it. Okay, so we're in this time travel mode, and you see the slider here way on the right, and I can go back 3 minutes ago, 4 minutes ago, whatever I want. I haven't really made many changes here, but I can go back to a previous version where presumably before I screwed everything up, and then revert to this, revert the live version to this, right? So that's a cool way of, I mean, that's a cool feature. Okay, otherwise, and I'm just going to put it back where it was and open the file. Otherwise, it auto-saves, but once in a while it won't auto-save, and you might, if it hangs up on a computation, which can happen kind of infrequently since we have this upgraded server or functionality, or it's a dedicated members-only hosting, it should pretty much work as you want, but occasionally you might do that. You might hit save. Okay, so let's close this off. You have to get the hang of navigating around the site here. Notice, so we're in Mike Archero, which is, I have myself as a student in here. So here I have any things that I've opened up. Okay, here's my time travel. I'm going to close that off. I've opened this as, I mean, this is just the sheet we were working on. If I go back to files, so notice I can go between files and the sheet that I have open. So if I go over to files, you can see where are all my files? Well, here's the file within the DE example. If I want to go back to the home folder, it's here. So now I'm back in the home folder. Suppose you wanted to just do open a Sage worksheet just to do some quick and dirty computation. You can come over here to New, and you want a Sage worksheet. And now maybe you type in a title here, or you don't have to, it'll just name it. And then you just do this, and now you've got a new Sage worksheet. So suppose I wanted to solve an equation. I would say solve x squared minus 3 equals 0. And I want to solve that for x. Okay, or maybe I want to integrate something. Plus or minus the square root of 3. That's good. And notice if I just kill that or close it off, it still should show up. It's in my home folder, right? And it, you know, it auto-saved, so it auto-saves pretty well. You can presumably also get a new worksheet by clicking on New. I think before, what did we do? We clicked on New over here. New Sage worksheet, right? You can do it over here. Sage worksheet. Okay, so as with a lot of applications, multiple ways to do things. Okay, so let's go back home and let's go over to our homework 3 template. And you can see there's a due date here. Let's go ahead and open that up. So here is the homework that you've been assigned, and when I collect it, the work that you enter here will be your assignment that you're graded on. So I've kind of guided you or started off a number of these. What I want you to do is use Sage to confirm any of your hand calculations, and also to do some of the plots and things like that. And also solving some of the equations you don't want to do with by hand anyway. There's a couple of them. If you're solving an algebraic equation. We talked about how the output displays when you use typeset true. So here's 2.1 number 1. I'll let you guys go through and do that. Again, if you want to see what how we produced this typeset, you can come up here and look at the markdown. Over here, you're going to use dsolve command with where you have to fill in the blanks here with the proper parts of the dsolve command. Presumably, let's see, we've defined x and y, and so we don't need to define function y and x. It's already been defined above. Sometimes you'll see that I'm doing that because this was copied and pasted. Maybe we didn't need to redo this, but now actually y is a function of x, which I guess it was up here too, which is fine. Okay, so you need to work through these, and most of it's commented the way that I don't need to repeat it in the video here. I think you get the hang of it. A note about how to get a numerical result. Let me see if there's anything else. At some point, you're going to be asked to, from here on out, you do the problem statement. So in other words, I want you to type out the problem statement and use LaTeX if you need to, and then type out the code. So, and, I said you have to do it from here on out, but actually I did the next two. So 2.2 number 14, and then a note about LaTeX commands beginning with a backslash. Let's look at the markdown language, or the markdown code here that produced this. So here again, double dollar signs make the typesetting nice. So I mean, this isn't so bad for you to figure out simple mathematical expressions. You use dollar signs. Double dollar signs will make it displayed on its own line like this. LaTeX commands begin with a backslash, but if you just have a backslash by itself, it just creates space. So that's all that these two backslashes are for. Create a little bit space between the equation and the initial condition. If I didn't have those spaces there, so it's the initial condition is kind of jammed up next to the equation. I don't like that, so I'm going to put a couple of those in there. Let's close this off. I think everything else is self-explanatory. So for 2.3 number 2, you are asked to enter the code here, and not the code, but the markdown. Enter the problem. You can actually cut and paste out of if you have a PDF of the text, you can actually cut and paste from the PDF, but then you might have to change a few things like dollar signs and percents. Here's one that I did as an example. It's not due for homework, but I wanted to show you. So dollar sign is telling Markdown that it's a LaTeX command. So if you just type a dollar sign, let's expand the Markdown here. If you just type a dollar sign, it's going to maybe think that it's LaTeX code. If you actually want to display a dollar sign within LaTeX or within Markdown, you should precede it with a backslash. Now, if you forget this in Markdown, it's still going to display even if you don't do the backslash. But it's good practice because in LaTeX, if you're doing a LaTeX document, a dollar sign, it will interpret it as math, and if you don't have another dollar sign, it's going to say it's a missing dollar sign. So you want a percent, excuse me, you want a backslash. Similarly with percent. Now you can see if percent has a special meaning in Markdown because this percent tells the cell, actually in Markdown and other languages or typesetting formats, you can see the percent lets it know that it's a markdown, lets the Sage know that you're doing markdown. So similarly, you'll precede the percent with a backslash. But so having said that, it still works. But notice, I mean, it still works even without the backslash. I just entered, and you can see the 9% down here still displayed as 9%. But notice how everything has the colored brown now. So the text is all brown because it thinks it's kind of a command. So it's a good practice to do the backslash here. All right, what else? And now I'm going to hide that. And this one was interesting that we did this in class. It's the lone example. So it's pretty much self-explanatory. The twist here is that we left the initial condition as some parameter. So the initial condition, we don't know it's fixed but arbitrary. Okay, and I'm going to refer to that as SO here, or S0, no underscore. The underscore will come in, let's go up here, to create this subscript in LaTeX. I did use an underscore here. So in LaTeX, an underscore will be a subscript. Okay. Now what? So we solved the equation, and I went ahead and did this, but you should go ahead and re-execute that command to see that it works. I mean, it's going to work for you. Notice I had the typeset to false because I'm going to take this and cut and paste it because I want to set this equal to 0 when t is 20. Okay. So notice when I do that, so this is a e. It still has e to the power with a caret there, but in Sage it's exp. So we had to change. Let's see, where are we? We're down here. So we had to change the e to the power with an exp over here, and notice set t equal to 20 here, and then the command is solve, and then you also have brackets, double equals, etc., etc., and there you got it. So if we want a numeric, this is the initial principle, right? So if you want a numerical result, we're going to copy this and paste it down here using the n command. So n gives you a numerical result. All right. So if you need help with Sage, well, for the most part, everything is going to be given by example, but you can Google and get lots of Sage help. In the other Sage tutorial in your home folder here, there are some resources listed. If you went back to this Sage intro here, actually the Sage beginner tutorial, there's some places listed, but they pretty much, if you Google them, those resources will come up. But you're not going to have to do too much of that. Let's go back to, notice I can go to my files and go elsewhere, and I still have this Sage worksheet open, so that didn't go anywhere if I go back to files. Here's another cool thing though. If you look up at these palettes here, I can produce a PDF file, you know, and I'm just going to say generate the PDF. So for producing reports, this kind of thing is handy, because what are you going to do when you're producing reports that have mathematical calculations or computations in them and also text? Are you going to use Word and point and click and cut and paste? No, you're not going to use Word. You're going to do something like this. You might use a combination of, like this Sage platform is working for us. LaTeX is another. Oh, there it is. Okay. You know, the markdown looks almost as good as regular LaTeX, but okay. As you know, we did use these commands here, or these mathematical expressions were typeset in LaTeX, so they are LaTeX. So I've created that. Anyway, I created that PDF file, and now it shows up in my folder here. See that? Okay. That's pretty cool. And I'll also want you to generate the PDF. Why not? It's quick and easy, and then it will show up in here. And again, I can go back to my home folder, and okay, see you in class.